Hello, let us discuss AMC 12, year 2015 B, problem number 25, which is called the flying bee problem. So I hope you guys had a chance to see the problem on the screen at the beginning. If not, please rewind and check it out. This video will be the first of the many part video. The sequence of the videos will be this. I'll introduce you to the problem, discussing what they want us to do and what are some specific things. We need to do this in order to make sure that we properly understand the situation and also know the goal. Number two, I will introduce a way to solution by using simple XY coordinate analysis. This is the simplest, yet it might be the one that takes the longest time. It still is very informative in its own way, but if you think about the AMC as a 25-minute test that it has to be done in 75 minutes, then it might not be the most effective way to approach this. Number two is an interesting twist to the whole thing. You can actually represent the whole situation with vectors. Vector representation let us to do something that cannot be done by other representation, and it can lead us to some of the ways we could handle other cases where you have vectors kind of radiating out in a periodical fashion. And finally, the fastest way to solution is by using complex plane representation. I will introduce this the last because in a way, it is the one that involves highest level of the math. And there are several techniques involved with underlying theorem, which I hope to get into. Some I will have to skip because it will just take too much time. So I have videos about this. Hopefully they'll be done in a reasonable number of episodes. So let's discuss this problem in depth. The first sentence reads, a bee starts flying from point P0. Okay, let's put the point P0. She flies 1 inch due east to point P1. Now we have a direction involved. It is very important to make sure that the direction is something that everybody can easily understand and mark it clearly so you will not get confused by it after all the things that you might be writing on it. So I'll use the most common direction they use, namely making the up direction north. If you make the up direction north, then the east has to be to the right. So B will be flying 1 inch east to P1. Okay. For J greater than or equal to 1, okay, so they want us to continue on after this. Once the B reaches point PJ, okay, so I guess that means that this is point J equals to 1, and that was J equals to 0. She turns 30 degrees counterclockwise. Okay, the bee used to be traveling in this direction. Counterclockwise is here, so for our situation, it is due north from where we were. And 30 degrees. So the new direction is 30 degrees north of east. And then flies J plus 1 inch straight to point PJ plus 1. So we are at J equals to 1. J plus 1 is of course 2. So we are flying 2 inches and has arrived at point P2. When the B reaches point P2015, she is exactly A square root of B plus C square root of D inches away from P0, where A, B, C, and D are positive integers and B and D are not divisible by square of any prime. So they want to know where point P2015 is. What is the distance to this point from the P0? So if that P2015 is here, what is this distance? And then they want us to write the D in the most simplified radical we can manage. And after all that, what is A plus B plus C plus D? Well, let's get the distance first. So let's continue this for just a little couple more times. At P2, we now need to go to P3. So 30 degrees counterclockwise again. That's 30 degrees. Now, the direction we're really pointing to is actually, if you draw a parallel line to this blue line, 60 degrees north of east. So a nice thing, 30 plus 30 is 60, that's good. And then 3 inches. So here's P3, 3 inches. Let's do one more. If we do one more, we have to turn 30 degrees again, and wow, 30 plus 30 plus 30, that's 90. We're heading straight north. And now the distance is 4 inches. I kind of ran out of the board here. So what would happen if we continue this? Well, I made a graph of the first 78 points, and this is how it looks like. Notice that it looks like a spider web with periodic structure that's radiating out. So there must be a reason why things look this regular, and there is some kind of pattern to the whole thing. In the next episode, when we discuss XY coordinate analysis, we'll try to see why there is such a pattern like this, and then how we can take advantage of this pattern to get the location of point P2015 and our answer. So see you at the next video.